All right, guys, here we go. It's 10:01. So, yes, I know that today is picture day, and they'll probably be calling you guys out. I'm gonna guess you guys are the last group to go because you guys are juniors and seniors. So it'll probably be closer to 11:30. So hopefully by that time we're just working on our delta, and then we'll just go. I think juniors will probably be called out first, but so you guys might be called out around 11ish. So here we go, guys. Intermediate value theorem and more on continuity. So here's our first example. We're just going to go right into it. It says consider the function, and now it's a piecewise function. Hopefully we're getting really good about pieces. To answer the question below, what two limits must be equal for g of x to be continuous? Of course, you need more than just the two limits to be continuous. You also have to, at that point, that has to, okay, Chop, what are you talking about? So real quick, don't write this down, just listen. Not only does the limit as x approaches some value from the left have to equal the same thing as the limit as x approaches some value from the right of that function. Not only do I have to have a limit, but I also have to have the function evaluated at that moment. It also has to have that same y value. So this is the definition of continuity that we did way back then. I don't remember what notes, but do you remember when we said like, okay, so it also has to equal that for it to be continuous. All right, so now let's talk. And I know these are my notes. These are the notes that I typed out myself. What two limits must be equal for g of x to be continuous? Well, for g at -2. For g of x to be continuous at -2, the limit from the left, which I hope you guys know, this is the one from left of 2, must equal the limit from the right. This one right here, I'm going to put right in quotes of 2, because it also is left of 3, but we're not there yet. So I must have limits as x approaches 2 from the left of kx squared plus m must equal limit as x approaches 2 from the right of 4x plus 1. Are we still okay? We're okay? Have we done anything crazy? Okay. Based off of what direction I'm coming from, right? Which, by the way, this one we can actually figure out what that value is. You just plug in a 2 to the middle one here, but we'll get there in a little bit. Maybe I should rewrite. Let me put rewrite because I'm not rewrite these notes for next year. Rewrite, or you guys tell me. Maybe I'll stay with the same. Letter B. What two limits must be equal for g of x to be continuous at x equals 3? Well, limit as x approaches 3 from the left better equal limit as x approaches 3 from the right. Now, if I'm approaching from the left, I'm actually using this middle one here. Do you guys see that? This one here is left of 3. See, because it's between 2 and 3. And then this one down here, well, I guess let me circle the expression, is right of 3. Say it again. How do we know when each question we're going to the right or left? Based off the restriction for the domain. And when you do a number line and you put 3, to the left of 3, those are numbers smaller, like 2.9, 2.5. And notice what it says here. It says x is between -2 and 3. So there it is from the left. And then this one says x greater than 3. So that has to be, those are a number larger than 3. So that's from the right. You know what I mean? Did I answer your question? So limit as x approaches 3 from the left of this function, which is 4x plus 1.
Please pardon this interruption. At this time, can we have the last half of 8th grade M through Z to the auditorium for your photos? Thank you.
Thank you. So there it is. They still don't want us to evaluate it just yet. They just asked the question, what two limits must be? Are we still okay? Okay. Let's go to letter C. It says determine the values of m and k so that the function is continuous everywhere. Well, I'm looking at letter A. And so here's my equation number 1. Notice that if I do direct substitution for the right-hand side, that's 4 times 2, which is 8, plus 1, which is 9. So I better have, let's see, 4k plus m better equal 9. Does everyone know where that 4 came from? Okay. It's okay if you don't know, I'll tell you. That 4 came from plugging in a 2 into the x squared. 2 squared is 4. So put that in your notes, that 4 came from, I guess I can highlight it here. That 4 came from plugging in a 2 into that x squared there, guys. That's equation 1. Equation 2. Ready? I'm plugging in a 3 into the left-hand side. So 4 times 3 is 12 plus 1, 13. And that better equal 3k minus m. Does everyone know where that 3 came from? I plugged in a 3 into that x right there. Are we okay? Yes. Oh, you got the what? I plugged in 3 into here. 4 times 3 is 12 plus 1 is 13. That's me. It's all good. Okay. Here we go, guys. Here we go. You can do whatever method you want. I see a minus m, I see a plus m, and I see a 4k, and I see a 3k. So I'm going to rewrite it like this. I'm going to go 4k plus m equals 9, and I'm going to write 3k minus m equals 13. All I did, that's equation 1, that's equation 2. I just stacked them next to each other. This is why algebra is so important. If your algebra game is weak, then your calculus is going to be weak because then you won't know how to tackle it, right? So yes. From right here, I plugged in x equals 3 in there. 4 times 3 is 12 plus 1 is 13. All right, here we go, guys. I'm going to add them. When I add them, these ends are going to cancel out. 4k plus 3k, 7k, and then 13 plus 9, 22. How do I get the k by itself? Yes.
For the first equation, shouldn't you be plugging in a -2 instead of a positive?
I did plug in no, it's a 2. Oh, and that says -2. How come you guys didn't help me with this? See, I make mistakes all the time. Am I approaching 2 or -2? So it was wrong from way over here. I'm going to put it in black. -2 and -2. Yeah, so that means that, let's see, that's still correct. 4 times -2, relax, it's a simple fix. 4 times -2 is -8 plus 1. So change that to a -7. Change that to a -7. And then change that 22 to 3, 4, 5, 6, to a 6. I bet you I didn't make that mistake last year. I'll look at last year's video and call it this year's. No, I won't do that. I messed up. That's okay. Are we okay? Is everyone all right? Okay, I'll make sure to put like an emoji on this video, like an angry one or something, you know? All right, next, to get the k by itself, you're just going to divide. Yeah, I remember. I'm going to change these numbers. Change numbers. Because then we get chaos. 6, 7. Let the record show that the right side of my class is all waving their hands in 6, 7 motion. Well, 2 people specifically. Yeah, Lizette Rodriguez and Annabelle Gonzalez. Full name. No FERPA here. Well, we're not talking about grades. We're talking about 6, 7. All right, here we go. Let's. Is number 2 correct? Oh, hold on. We just got the K. We still haven't gotten the M. We still haven't gotten the M. So it doesn't matter what equation we use. We should get the same M value regardless. What equation do you want to use? 1 or 2? 2. All right. So here we go. 13 equals 3 times 6 over 7 minus M. I'm going to move the M to the left. I'm going to move the 13 to the right. So let's see. M equals 6 times 3. What's that? 18? 18 over 7 minus 13. And I don't know. Should we do common denominator and then see what this is? Or just leave it like that? Or like that? Okay, that's fine. I'm okay with that. Ask me.
I just don't understand like how this works. So you're kind of just telling me what to do and I'm like writing it down.
Oh.
But I don't understand why we're doing this.
Because those k and m values will make this function continuous. Remember that when the y value of this top line has to equal the y value of this middle line. And those k and m values that we just found will make the y value of the top equal the y value of the bottom. Does that make sense? Yeah. And then, of course, the bottom one doesn't have a k or an m. The third equation here has a k and an m. So if I put the k and the m values here, that will make that y value be the same. I don't know. Maybe we should figure it out. Maybe we should go to Desmos and see if that works. You guys want to see that really quick? All right, so here we go. Let's see what this is. What is this? 18 over 7 minus 13. So let me go to Desmos. Desmos. What was it? I already forgot it. 18 over 7 minus 13. 18 over 7 minus 13. Okay, so negative 73 over 7. Oh, yeah, my short-term memory is bad. M equals negative, see, I already forgot. Negative 73 over, was it 7? Negative 73 over 7. I didn't do that on purpose, or maybe a little bit, probably. All right, check it out, guys. Check it out. Notice that your K is 6 over 7, and that your M is negative 73 over 7. Are we okay? So watch. Look what happens if I were to graph this. So let me go ahead and graph this in pieces. F of x equals, and what was my top equation? Kx squared. So instead of K, tell me 6 over 7. Look what you did, Ms. Gonzalez. 6 over 7, x squared. What else do I have? Minus what? Or plus what? Negative 73 over 7. Okay, and then I'm going to put a bracket, curly bracket, for x less than negative 2. And end curly bracket. So there it is. Do you guys see that? All right, look at this one. Now I'm going to put g of x and give me the middle term. 4x plus 1, and I'm going to put curly bracket from, so negative 2 less than x less than 3. And look at that. Do they have the same y value? Yes, they have the same y value. And now look, this one's going to stop at 3. And now, all right, guys, focus. H of x, give me the last one. 6 over 7x plus negative 73, right? Oh, okay. Plus 73 over 7. And then I'm going to say for x greater than 3. I know it says greater than or equal to, but this doesn't. And then look, see how all the y values touch? So it's continuous. Are you satisfied, guys? Did I answer your question? Okay. Yeah, ask me questions, guys. Ask me. I can't read minds. Okay. Here we go. Next one. I think we already did this one, no? In UH. Oh, this one they haven't asked you this one yet? Okay, it's coming. Quiz 2, limits 2 is going to be the next one. I'm going to probably release it tonight, and I'll probably make the due date. I kind of want to make the due date Friday, but if you guys want me to make the due date Sunday, I can. Sunday. All right, but guys, are you going to make an attempt so you can ask me questions? Yes. Okay, I'm going to put on Canvas. I'm going to make you guys do the notes. Relax, it's for a reason. It's because that way you get the experience already. You know what I mean? And so yeah, you'll see it on Canvas tonight. So actually, you'll see it on Canvas probably before even lunch starts. All right, here we go. It says, given that f of x equals this, define the function f of x at 5 so that it becomes continuous at 5. Okay, the only way you can make any function continuous is if it has a hole. That's the only way. That's called a what? Starts with the letter R? Removable discontinuity. Way to go, miss. Yeah. So if it has a removable discontinuity, it can be you can fill that hole in and make it continuous. So that means I gotta check to see what the limit is. If it has a limit, that limit is a hole. If it doesn't have a limit, then that means it's a vertical asymptote. Does that make sense? So I'm gonna find the limit as x approaches 5. So I'm gonna write limit as x approaches 5 of this function, square root of x plus 4 minus 3 over x minus 5. Are we okay? Okay. I'm going to draw a giant parenthesis. What's making this tough? The numerator or the denominator? The numerator. So I'm going to multiply by the conjugate of the numerator. X plus 4 plus 3 over square root of x plus 4 plus 3. There it is. That's kind of like the difference of squares. So now here's what I now have. I'm going to have limit as x approaches 5, giant parenthesis, square root times square root, the square root goes away, x plus 4. And then negative 3 times positive 3 is a negative 9. And on the bottom, don't distribute, just leave it as x minus 5 as a product of x minus 5 times x plus 4 plus 3 close. So do that. Are we still okay, guys? All right, that 4 minus 9 turns into, there you go, x minus 5 over, and then x minus 5, square root of x plus 4 plus 3. Close it. So catch up to here. I hope you brought fries. Catch up.
I like that one actually. That was a really good joke. That was good.
I have one more good joke left, but I'm not going to use it yet. All right. I have a fraction. I have an x minus 5 in the numerator, and I have an x minus 5 in the denominator. This division here, that means that I can cancel the x minus 5 factor. Bam, bam. And now can I do direct substitution? Yeah, because now I don't get a 0 in the denominator. So I have 1 in the numerator, and on the bottom, 5 plus 4 is 9, and the square root of 9 is 3, and 3 plus 3 is 6. Now, we haven't answered the question. We just know that has a limit. So it says, define the function f of x at 5 so that it becomes continuous at 5. Okay, well, if you just want to define it, you just go f of 5 has to equal 1/6 for f of x to be continuous. To be continuous at x equals 5. If you wanted to do a piecewise function, you can. You can write f of x, and you can say, where's the function? Square root of x plus 4 minus 3 over x minus 5, as long as x does not equal 5. And then you can write 1/6 if x equals 5. And there it is. There's your function. And let me zoom in so you guys can see. Is that making sense to you guys? If it makes sense to me, it'll make sense to you. Because I'm not that smart.
Wait, why does it not equal 5? Like in the first.
Please pardon this interruption. At this time, can we have ninth grade? Ninth grade, last name.
Yeah, there's a hole at x equals 5.
Ninth grade, last name.
You can't divide by 0.
Report to the auditorium for your photo.
If I had 2 holes?
No, you got like instead of taking out
But they're telling me that I'm defined at 5. And that's wrong. Do you like that quote, guys? If it makes sense to me, it makes sense to you. That might be my new YouTube slogan. If it makes sense to me, it makes sense to you. All right, guys, here we go. This is our first big theorem. All right, guys, focus, focus, focus. This is our first big theorem. This one is a big deal. This one is tested, and you're going to 100% see it. It just depends. I'm not saying that I don't know how it's going to be presented. I could do. But, every year it changes, the variations, obviously, the situations. But 100%, this is going to be in there. Intermediate Value Theorem. Relax. It's not a big deal. The acronym is IVT, but I recommend that you do not use the acronym, that use say the whole thing. Intermediate Value Theorem. Okay, read this right here to yourselves and tell me if it makes sense to you. Did it make sense to you? Okay, so it made sense to one person. Everyone else? Okay. Let me tell you what this tells you in layman's terms. Does that mean like simple? Okay, in layman, why layman? What is a layman? Is it a cave person? See, I don't know. I don't know all these things. All right, here we go. Here we go. Draw a picture like this, x and y axis. Draw a continuous function. Put a point below the x-axis, put a point above the x-axis. And then draw a continuous function. It does not matter how. Matter of fact, maybe some of you should draw it like this. Maybe some of you should draw it like this. Oh. I did that on purpose. LOL. No, I didn't do it on purpose. I did draw the same thing. It's a Monday, guys. It's a Monday. I have a whole bunch of tricks. Maybe I did it on purpose. You guys entertained. All right. Here's the question. Here's what the intermediate value theorem says. All right, guys, focus. So here's what the intermediate value theorem says. If you have a point below the x-axis and you have another point above the x-axis and the function is continuous, did I cross the x-axis? If it's continuous, you must. How many times did you cross it? I don't know. On this blue one, we crossed it 3 times. On this red one, you crossed it once. You do not know how many times you crossed it, but you know you crossed it. That's what the intermediate value theorem says. So this picture here that they have, here's what they're trying to say. They got a y value. You see where it starts at A, that f of A is a y value. And then at B, they got this y value right there. And they're saying that this curve took all the y values between f of A and f of B. That's the only thing that's guaranteed. Did I get a y value above it, above f of B? Well, it looks like yes, but is it guaranteed? Well, not if you don't have extra information. Does that make sense? So you got all the values between f of A and f of B. Did I go above it? Maybe, I don't know. But for sure, because it was continuous, I got all the y values between f of A and f of B. Does that make sense, guys? Like, okay, so yeah, and then there it is. Here it is in pictures. If I have a point below the x-axis, if I have a point above the x-axis, did I cross the x-axis? Yeah. How many times? We don't know, unless we know how the graph looks. But if it's continuous and you give me a value below the x-axis, a negative, and then a positive y value, I know for a fact that I crossed the x-axis. How many times? We don't know. But we know because it's continuous, you crossed it at least once. That's intermediate value theorem. Cool or not cool? Okay, look, we're going to give you another one right here. Gonzalez, do you want to read example 3 for us, please?
You're driving to a calculus Saturday session for your first month exam, which happens to be your favorite class because you often made it in a past exam. Yay, go Cardinals, hashtag not like. You look down.
Okay, keep going.
You look down at your speedometer. It says 55 miles per hour. Did you at any given moment before the instant looked at? Wait, sorry. Did you at any given moment before the instant you looked at your speedometer travel exactly 52 miles per hour, 59 miles per hour? Okay, do we understand the situation? So you're driving, and then you just look down, and the speedometer, when you look down, says 55. At that exact moment, when you look down and it said 55, at that exact moment, did you at one time travel 52? You had to, because it's continuous. Did you travel 59? It's possible, but is it guaranteed? No, that's what the intermediate value theorem says. So if someone were to ask you, did you travel 59? You're not going to tell them no, because that's definitive. You're going to say, maybe. We need more information. It's not guaranteed by the intermediate value theorem. Maybe we hit 59. But if they ask you, did you hit 52? You're going to say, yes. By what? By, what's the name of the theorem? Yes, by intermediate value theorem, since velocity is continuous, I definitely have to go 52. Of course, in real life, you probably wouldn't tell them all that, right? You would just say, yeah, of course, I hit it. But, okay, whatever. Does that make sense or not? Okay, cool. So I'm just going to put happy face there, and I'm going to say that was the classroom discussion, and you can refer back to this video. Refer to this discussion in this video that I'm going to post in a little bit. Okay, are we still okay? All right, here we go. Look at this question. And I know, look, I just told you not to use IVT. And here I am giving, with my own bad advice, using IVT. So I'm going to put here rewrite. Do not use the acronym. Use the entire thing. Intermediate Value Theorem. Can the IVT, Intermediate Value Theorem, be used to show there is a solution for the equation f of x equals 0 on the interval 1 to 2 if f of x equals all that expression? Give an explanation why. Okay, is f of x continuous? Is it continuous? Yeah, it's continuous forever on the entire domain. It's continuous for all real numbers. It's a function, it's a polynomial. All polynomials are continuous. You're always defined. 3x cubed, 5x squared, x minus 3. You're always defined. If it were a rational
If I had a denominator, then you're not defined when the denominator is 0. But I just have a polynomial, you're always defined. We're okay? Are we entertained? Okay, don't worry, I'll get a soundboard and we'll be more entertained. Okay, all right, you guys ready? Here we go. I want to know if I hit the x-axis. Well, here's what I'm going to do. I'm going to figure out what f of 1 is. Yes, could you have plot this equation in the calculator and see if it crosses the x-axis? Of course. But what if we don't have a calculator? I'm going to plug in a 1, and let's see what this y value is when x is 1. 3 times 1 cubed minus 5 times 1 squared plus 1 minus 3. Let's see what that is. 3 minus 5, that's negative 2. Plus 1, that's negative 1. Minus 3, that's negative 4. So far, I just know that this is negative. Here's how you say negative. You just say below 0. Less than 0. All right. Are we still okay? I'm going to figure out what f of 2 is. 3 times 2 to the third power. Child, why at 2? Because I'm looking only at my domain between 1 and 2. Minus 5 times 2 plus 2, minus 3. And I'll slow down. Do you guys know what I'm doing? You can say no if you guys don't know. What's up?
It's a square.
See, I almost messed up. Squared. Hopefully I would have noticed that one, I hope. Child, what are you doing? I plugged in a 1 because this is my interval, and I wanted to see what the y value was at 1. I got a negative 4. I plugged in a 2 because that's my endpoint of this interval, and I'm trying to see if it's negative. If it's another negative number, I cannot prove that it crossed the x-axis, but if it's a positive number, then it definitely crossed. How many times? We don't know, but it crossed at least one time, at least. Cool or not cool? All right, here we go. Let's do it without a calculator. So 3 times 2 to the third power is 8, and then 2 squared is 4. So I guess I'll write it like this since I haven't evaluated the 1 at 8. 5 times 4 plus 2 minus 3, so I'm going to say minus 1. All right, 3 times 8, 8, 16, 24. And then 5 times 4, 20. All right, 24 minus 20 is 4 minus 1 is 3. That is larger than 0. Did I cross the x-axis? Yes. So we're going to say, you're going to write a quick statement. You don't have to be an expert, guys. You don't have to, you don't, as a matter of fact, don't write an essay. Just write 2-3 sentences at most. You're going to go, f of x is continuous on 1, 2. If you want to put x subset, that's fine as well. Since f of 1 equals negative 4, and since f of 2 equals 3, comma, by intermediate value theorem, comma, f of x must equal 0 somewhere on the interval 1, 2. Notice that I put parentheses on the 1, 2 because right at 1 it was negative 4, right at 2 it was 3, so it's not happening at 1 or at 2. But it's okay if you were to put brackets, we still would have been fine.
So would this be like, is this just going to be like a question of the event, or would this be like an FRQ?
It could be both. It could be multiple choice, FRQ, whatever. Yeah, no, yeah, just prepare. Don't worry, we're gonna prepare you guys.
Are the FRQs like pre-cal were the same? Like,
Yeah.
Okay.
Yeah. There's still some, overlap, but yeah, it's not like in pre-cal where all the ones are the same, all the two are the same. Now they're just gonna be. All right. Here we go. It's a exam since been around since the 50s, versus an exam that's been around for 3 years. All right, here we go, guys. Here we go. I cannot pronounce this. Do we have anyone from Louisiana in here? Atchafalaya? Is that how you say it? Oh, okay. All right, Ms. Gonzalez. I'm not picking on you, I promise. Do you want to read this for us? Okay, she's going to read it. Read it out loud so my YouTube fans can hear. Okay.
Please pardon this interruption. At this time, can we have the last half of ninth grade? That's last names M through Z for ninth grade. Report to the auditorium for your photos. Thank you.
All right, go for it, Gonzalez. Here we go, guys.
There's a law of Ashafal Bassett Bridge. True story, guys. Tell your parents about this one. The bridge is 18 miles long and it is in front of I-10.
Okay.
The law allows use of cameras to support issuing a ticket based on how fast it takes a vehicle to get from one end of the bridge to the other end. Drivers who cross the bridge in less than 18 minutes will receive a speeding ticket in hand.
Okay, this is true. So you guys that are starting, there's tolls in Texas, right? So for you guys that are starting to drive, whenever you drive a toll road, if the speed limit's 80, 85, and you're going below it, then you don't have nothing to worry about. Whatever the speed limit of that toll road is, if you're going above it, I would do a side stop. I'm not asking you to break the law here, but if you're going above that speed limit, I would definitely do a side quest and get yourself a burrito on a gas station. So your average speed will not be, so this doesn't happen to you. So Chav, what is this? So it's 18 miles long, and if you finish in 18 minutes or faster, you get a ticket. What's the speed limit? It's 60 miles an hour, because if you're going 60 miles an hour, you travel 18 miles in 18 minutes. Does that make sense? And this is true, guys. This is true. There's a camera in the front, and there's a camera 18 minutes outside, or 18 miles outside of that 18 minutes. So it takes a picture of your license plate, and when you get in, and then when you leave, it takes another picture, and it takes that time, and it calculates your speed. And if your average speed is above the 60, guess what? Ticket. But if you stop somewhere, if you do a quick mini stop, is this making sense, guys? Okay. So what is the speed limit? 60 miles per hour. Make sure that you guys know how to calculate it. If you don't know how to calculate it, I can show you. You're just going to have to convert it, right? So remember that this is miles per hour. So I'm going to go 18. Let's see. 18 miles. And I did 18 miles in 18 minutes. So I'm going to write miles per hour. So I need it in the bottom. So I'm going to write 18 minutes. And then I'm going to say in 60 minutes, there is 1 hour. There's your conversion. Minutes cancel out. And you got miles per hour. 18 cancels out. 60 miles per hour. Maybe this is not the most nice and fluent one. There's probably better stoichiometry or dimensional analysis, but I just did it that way. Does that make sense, guys? Okay. Use intermediate value theorem to explain, is this law fair and just to all drivers? Why? And then I used to make a 1 minute video, so I'm going to delete that. I used to make, like years ago, I would make my classes do a little speech, and they can come up and present, but not that I don't want you guys to have fun, but we're running out of time. We look at the date for when we were supposed to do this. Scheduled for August 21st. Are we August 21st? Yeah, so sorry, I'm not trying to take time away from you guys. I just don't want to, if we would have been on time, we would have done that. That's what we would have done. Yeah. All right, use intermediate. Okay, thank you, miss. But ask me, though. I still want you to ask me. All right, is this law fair and just? Yes. Yes. What are they using? Are they using, what theorem are they using? Yeah. Using intermediate value theorem. And YouTube, if you guys have experience, you're probably saying that's also mean value theorem. It is. It could be. But we're rookies right now. This is our first rodeo, so we're just going through this. Don't worry, you're going to learn mean value theorem. We're just not there yet, guys. We're not there yet. Are we still okay? All right, here we go. These are like questions from UH Quiz 3 and 4, which we're about to release. And I know some of you are really fast, so I'll release UH Quiz 3 and Quiz 4 on Canvas for those of you that are going really fast. But I'll make the due date still much later, So don't worry, you guys are fine. All right, here we go. Give the value a and b for the function f of x to be continuous at both x equals 1 and x equals 6. Ready, Herrera?
Yes.
Hey, don't worry, no pressure.
Oh, you want me to do this? it.
No, we're all gonna do it. Look, no, we're all gonna do it. Relax. Look, in order for this function to be continuous at x equals 1, the y value of the top has to equal the y value of the middle. Because as I approach x equals 1 from the left, the y value of the left has to equal the y value from the right. Does that make sense, guys? Okay. Same thing with at 6, the y value as x approaches 6 from the left has to equal the y value as x approaches 6 from the right. So both sides. No, I'm not doing the thumbs up, miss. You're the one that told me. I'm just doing this. Man, guys. All right. I've been doing this for decades. Like this. Okay. They're trying to be bad influences. All right, here we go. So here we go, guys. I'm going to write limit as x approaches 1 from the left. If I approach from the left, I'm looking at ax minus b. Do you guys see that? Better equals the limit as x approaches 1 from the right, which is 15x. Are we still okay? All right, so here we go, equation 1. So I better have, I'm plugging in a 1. So a minus b better equal 15. Are we all right? All right. I'll stop. All right, limit as x approaches 6 from the left of 15x better equal limit as x approaches 6 from the right of bx squared minus a. Ooh. Are we still okay? Here's equation 2. 15 times 6. Well, I don't know. Let's see. 15, 30, 60, 70, 90. So 90. Yeah, let me make sure. I make mistakes all the time. What's up?
How do you do first equation
Equals. Are we still okay, guys? All right. 6 squared, what's that? 36b minus a. We have a system of equation. It doesn't matter what you do now. Whatever. Now it's just algebra. We're done with calculus. Now make sure everything's correct, guys. Is 15 times 6 90? Yeah, I think it's 30, 60, 90. Yes. All right, here we go. I'm going to write, let's see. I'm going to write, what am I going to write first? I'm going to write number 1 first. I'm going to write a minus b equals 15. And I'm going to write this one next. I'm going to put the negative a in the front. Negative a plus 36b equals 90. And I'm going to add them. And when I add them, those a's are going to cancel. Do you guys see that? So those a's cancel out. And I have 35b equals 105. Are we still okay? I'm going to divide by 35. And I want to say that it goes in perfectly. 30, 60, 90, and then another 15. Yep. So b equals 3. Now that I know what b is, I can use whatever equation you want. You should get the same value for a no matter what. The equation that looks easiest to use is the first one because the coefficients are 1 in front of the a and the b. So I'm just going to go a minus 3 equals 15. So that means a equals, there you go. Are we okay, guys? All right, let's go now to, all right, so we're pretty much done. This is just a quick overview of how to tackle these questions. Why are we doing these right here? They don't really look like they're calculus. Because you're going to see them in one of the UH quizzes, and you're actually going to be using these a lot when you're doing analysis like of the graph. Is it positive? Is it negative? All right, so you see how it says, I want to know where this is greater than 0? So tell me where this equals 0. We're going to call those, well, eventually we're going to say where the derivative is 0. Those are critical numbers. But for now, we don't know that word yet. Forget you even heard it. Where is this equal to 0? It equals 0 at x equals 5. And 4 times what is 28? So x equals 7. Yeah, because 6 times 4 is 24. So 7 times 4 is 28. All right, here we go. I'm going to do a number line. Well, I call this, for the longest time, I called this a railroad track. But then Dr. George from UH was like, you call that a railroad track? Like, yeah, Dr. George, it looks like a railroad track to me. And she's the one that said, that's a sign chart. Call it a sign chart. I'm like, no, Dr. George, it's a railroad track. So for respect for Dr. George, if you're watching my video, it's a sign chart, but I still call it a railroad track. Are you guys okay? All right, so here we go. all you care about is positive or negative. I don't have to worry about the x minus 5 because I see a square there, and that's always going to be positive. I'm just focused on the 28 minus 4x. If I plug in a 0 for x, 4 times 0 is 0, and I get 28 minus 0. Is 28 positive or negative? Positive. If I plug in a number bigger than 5, like 6, 4 times 6 is 24, and 28 minus 24, is that still positive? Yes. If I plug a number bigger than 7, any number will work, like 10. Try to use a number that's easy for you to multiply. If I use 10, 4 times 10 is 40, and 28 minus 40, is that positive or negative? Negative. All right, so here we go. It wants to know where the function on the left is positive. So I'm going to write x minus 5, since I didn't give it a name, so x minus 5 squared, 28 minus 4x is greater than 0 on, parenthesis, negative infinity all the way to 5. Close it. Right at 5, it's 0, so it doesn't equal 0, so I'm going to put that. And then, do you want to use a union, or do you want to use the word and? Well, I already wrote and. And, parenthesis, 5 all the way to 7. Good thing that 5 was not a 6. You guys over there would have done. What's up, miss?
Can you explain the number line thing again? It's
5 it equals 0, and then 7 it equals 0. And then I just check the number to the left of 5, the number to the right of 5, the number to the left of 7, the number to the right of 7. And all you care about is where it's positive because that's just greater than 0. Hit me.
I don't know what you mean. I got the 7 one, but
No, 5, you get a 0 because someone's got a 0.
Please pardon this interruption.
So those are
You
critical
are on
numbers, that's
10th
right?
grade, 10th grade,
I'll show you
to the
that.
auditorium for your photos. Thank you.
Maybe this will answer your question. All right, guys, real quick. Why did I just focus on these numbers 5 and 7? If there's going to be a sign change, if there is, I have to cross the x-axis, right? At 5 and at 7, if you call this a function, at 5 and at 7, this function is hitting the x-axis at 5 and at 7. And then I analyze it to see if there's a sign change, if I change from positive to negative or vice versa. And then I just care about all the ones that are positive. So if I have a sign change, it's going to happen at 5 or at 7, if I have a sign change. And notice I did have one at 7, and went from positive to negative. Did I answer your question? How do we feel, guys? Okay, so look at this one here. It says solve the inequality. Nothing cancels out. If I were to factor out a 2, you get x minus 5 in the numerator. So you need 3 numbers. You need to know where this has vertical asymptotes, and you need to know where this function equals 0. So I'm going to write, I should have given it a name. Too bad I didn't. I'm going to write f of x equals that, guys. I'm going to write f of x equals 0 when x equals 5. And let me see, what else am I going to write? Vertical asymptotes at x equals 2 and x equals 8. Are we still okay? All right, here we go. I'm going to do a railroad tracks or a sign chart. And I'm going to plug in, let's see, which one's first? 2. So I'm going to write x equals 2. And I'm going to, bless you, I'm going to write x equals 5. And then I'm going to write x equals 8. I'm going to call this f of x. So all I'm doing, I'm just like before, guys. You don't care about anything other than positive or negative, just a sign of the output. You guys ready? So give me a number to the left of 2, any number. 1, okay, I would have said 0, but you guys like 1, I'll use 1. 2 times 1 is 2, and 2 minus 10 is negative. Okay, so keep that number, that sign in your head, negative. 1 minus 2, positive or negative? Negative. 1 minus 8, positive or negative? Negative. Okay, negative times a negative in the denominator is going to turn into a positive. But what do I have in the numerator? Negative. So what's negative divided by positive? Negative. All right, so I'll put a minus sign to the left of 2. Do you see how we did it? Okay, what is between 2 and 5? 3. So yeah, any number, whatever you think is easy. 3. 2 times 3? 6. Minus 10? Okay, keep that keep the sign in your head. Negative in the bottom. Okay, we said 3, right? 3 minus 2. 3 minus 8. Negative. Positive times a negative. Negative. What happened in the numerator? Negative divided by negative. So this is a plus symbol. Give me a number between 5 and 8. 7. Okay, 7. We're good. 2 times 7. Minus 10. Positive or negative? Positive. Keep that number in your head. Well, keep the sign in your head. 7 minus 2. 7 minus, oh, that's positive. 7 minus 8. Positive times a negative. What did I have at the top? Positive divided by negative is? A negative. Give me a number larger than 8. 10. Okay, now everything's going to be positive. 2 times 10, 20 minus 10, that's positive. 10 minus 2, positive. 10 minus 8, positive. Everything's positive, so this is going to be positive. Okay, what does this mean? What does this mean right here, less than 0? What does that mean? I want what? Negative. So put that in your notes. That means negative. Anything less than 0 is negative, guys. So that's how you say negative in math. So what are my intervals where this function is negative? Negative infinity all the way to 2, parentheses, and 5 to 8. There it is, guys. Do you see how we're doing it? All right. I forgot to put the little snippets here of what we have, but it's okay. I'll tell you now. You have a delta math. You should be able to do all the well, the first 2 are just limits, but the third one is the continuity one, so you should be able to do that one now. If you want to do the third one first, do the third one. The third one's on this Intermediate Value Theorem and continuity. I'm going to release the UH quizzes. I'll put them on Canvas in a little bit. And that's it, guys. So we got a lot to do. And a little bit, they'll call you down for pictures. Cool? All right. Good job. We did a good job today.